All right. Me and Osvaldo are going to do our physics project on our love of science memes, right? Like, look at this one. Isn't this one just great, Osvaldo?
It sure is, Diego.
All right. Now, what about this one with the mitochondria? That's the powerhouse of the cell.
That's all I learned in biology.
All right, but now we look like this one's about cooking chicken by slapping it. And see, this has some number, but I don't think I'm happy with that number. Are you?
Not really.
All right. So if kinetic energy is converted into thermal energy, how hard would you have to slap a chicken to cook it?
Let's find out.
Let's find out. All right. So we know through physics, K is equal to 1/2 mv squared, and we're using K because moving your hand to slap a chicken, that's kinetic energy.
And kinetic energy can be converted into thermal energy, which equals mass times the specific heat capacity of the chicken times the change in temperature.
All right, so setting those equal to each other, we need the mass of a hand, which some quick research is 0.4925 kilograms. We need the mass of a chicken, which with some more quick research is 5.8 pounds, but that's in freedom units. If we want to convert it to something actually usable, that's roughly 2.6 kilograms. From there, we gotta find the C in the thermal energy equation, and that's 2.72 kilojoules. All right, and then in order for a chicken to be considered cooked, it needs to be brought up to an internal temperature of 165 Fahrenheit. But again, that's in freedom units. That's garbage. So with some quick math, we find out we need to basically bring the chicken from 0 to 74 degrees Celsius. All right, and with that, we have all of our math that we would need. So how fast would we have to slap a chicken, Osvaldo?
Alright, well, if we set these formulas equal to each other, we get 1/2 mv squared equals mc delta t. Now, you need to be sure to differentiate both these masses because we can't assume that they're equal to each other because that just don't work. Now, if we move some stuff around, we get v equals 2 mcc delta t over mh, and all that is under a radical. Now, if we plug in some numbers, we get v equals the square root of 2 times 2.6 kilograms times c, which if you multiply by 1,000 to get joules, it's 2,720 joules. And then delta t, which is 74 degrees Celsius. And then underneath that, we have the mass of a hand, which is 0.4925 kilograms. And then, if we plug that into our calculator,
Handy dandy TI-84.
that's right. It's gonna take a while.
All right, come on, we've all used the calculator.
Shh. All right. So that's a big number. And we divide by 0.4925. We square root our answer, and we get approximately 1,457 meters per second.
And now just to clarify, here are all of our numbers that we use to get all of this. This is the human hand, it's the chicken, it's the conversion, the heat capacity of said chicken, how hot we need to cook the chicken, conversion, and then our final conversion, which is you'd have to slap it at roughly Mach 5. And we just want to throw in, we're not counting for air resistance or for the energy loss of the sound of the slap.